Good afternoon to all the participants, and on the behalf of our research group, I want to thank the organizers for letting us present our results today. So let's start. Objects with extreme ultraviolet emission. What it is about. Large-scale photometric surveys have enabled the analysis of an unprecedented number of stars. Among these, objects detected in multiple surveys across different spectral ranges, for example, SDSS to MASS and WISE, are considered to be the most favorable and most convenient material for the research. Essentially, photometry obtained in the bands of different spectral ranges allows us to reconstruct their spectral energy distribution. However, objects that are found exclusively in one of the surveys and absent in all others should also attract our close attention. The search I'm talking about today is expanding our initial Pathfinder study conducted in Karpov with colleagues in 2021. In particular, we're looking for the galaxy objects that have no counterparts in two major optical sky surveys, Pan-STARRS and Dark Energy Survey. GALEX is a space-based ultraviolet telescope, and it was in operation for approximately a decade, conducting the most comprehensive almost all-sky UV imaging survey to date. Its legacy includes the catalogues generated from images and the photon database. This database enables us to reconstruct both images and light curves for any celestial point observed by GALEX. GALEX conducted sky observations in two distinct UV bands, near UV and far UV. These bands are located in the transparency window between Lyman and Balmer breaks. They are quite far from the ranges of typical optical sky surveys, which all operate in quasi-Sloan filters. This refers both to the Pan-STARRS and dark energy surveys. And for the reference, we depicted the spectrum of Vega in the bottom. When it comes to large-scale cross-matching of extensive catalogs, there are a couple of approaches. One option is to download all the data and perform the computations locally. The downside is that you need to have enough local storage space and memory to operate with these huge tables, which can be quite challenging. Another approach is to use the remote services such as MAST, SkyServer, or NoiLab, where you can submit tasks to be executed on the data directly. While this approach is convenient, none of the existing services offer all three catalogs we need. On the other hand, well-known catalog access service Vizier at CDS contains all of the catalogs. It does not, however, have a service for bringing arbitrary computations to this data, but it has a reliable and well-tested cross-matching service, XMatch, and we decided to give it a try for our task. I would like to remind you that we are looking not for regular matches in different surveys, but rather the objects that have no counterparts, which we call unmatches. This task can be a bit more complicated due to the fact that none of the catalogs cover the entire sky, and their cover area can be quite different. For instance, Pan-STARRS here in green encompasses the entire northern sky and part of the southern hemisphere up to 30 degrees. In contrast, GALEX in blue and light blue and DES in orange have more intricate and complicated footprints, which is harder to describe. To address this challenge, we devised a simple yet effective algorithm. It serves a dual purpose. First, it allows us to focus on common sky areas, and second, it simplifies the unmatching process down to two regular cross matches. Here is how it works. We begin with a broader matching step, specifically with a matching radius of 30 arc seconds. This step identifies all of the regions where the footprints of two surveys overlap. It's either galaxies with pan-stars or galaxies with DES. Next, we perform a second matching using a smaller radius of 3 arc seconds, which is optimal for galaxies. And to obtain a final list of objects that have no counterparts, we discard all the pairs that appear in the results of both first and second matching steps. This leaves us with only with pairs separated by more than 3 arc seconds. These are the unique galaxy objects with no nearby optical counterparts, yet still located within the optical catalogue's footprint. We employed additional criteria based solely on the content of Galaxy catalog to refine our datasets. This filtering process involved removing objects with non-zero extraction flags, which are used to identify issues like saturation, object blending, or truncation. Next, filtering out objects flagged by Galaxy pipeline as potentially affected by diachronic or window edge reflections. We retain only high signal-to-noise objects with signal-to-noise ratio greater than 5. And last but not least, we apply criteria to filter out extended objects. Further filtering was applied at the level of optical images to identify cases where a source was presented at the object's location but escaped automatic detection. This could refer to masked objects if they're too bright, or blended objects if in optical survey the object was resolved as binary, for example. Another challenge is the motion of stars. The data we are working with were collected at significantly different time intervals with span of up to 15 years. Over this period, nearby stars can undergo significant motion, resulting in objects that don't match between two catalogues. Fortunately, we have Gaia that reliably measures the proper motion for the majority of close and bright objects. And we filter out the candidates that have Gaia stars with a large enough proper motion within an arc minute. G-photon package grants us access to all of the photons ever detected by galaxies from any spot in the sky. This tool helps us determine whether the object is a persistent feature or a transient one. Additionally, with the precise time of each visit available, we can directly verify whether the transient is attributed to a known solar system object, such as an asteroid, like here. After applying all of these filters and removing any contamination, we arrived at our final list of candidates. From the combined galaxy and dark energy survey data, which together span roughly 5,000 square degrees of the sky, we have identified 27 asteroids and 1 stationary object. By stationary, we mean objects visible in multiple consecutive visits with consistent brightness. In case of pan-stars, which covers an area approximately 5 times larger, we have detected a greater number of asteroids, a greater number of stationary objects, and a number of other transients. Let's take a look at some visual representations of our findings. On the top left, you can see multi-wavelength cutouts of the stationary objects from dark energy survey. It's positioned on the outskirts of the galaxy, which certainly makes it an interesting object for further investigation. On other pictures, we have examples from pan-stars. These images, all of these three, reveal some signs of point-like objects near their position. This suggests that these objects could be either hot stars or active galactic nuclei. Looking at transients, we saw at least two different behaviors. One, like here on the left, rapidly increases in brightness and possibly a flaring star. The other remained visible for at least 20 days, suggesting a slower transient. Unfortunately, GALEX operated before modern all-sky time domain surveys like CTF or ASAS-SN, making it challenging to pinpoint the exact nature. And now I'm ready to make a conclusion. In summary, our approach involved cross-matching of multi-wavelength catalogues using GALEX and modern optical sky surveys, specifically pan-stars and DES. We were aimed at finding objects only visible in ultraviolet range, and our efforts resulted in the identification of several promising candidates, stable UV objects with no counterparts in pan-stars, along with various transients and known asteroids. These candidates now warrant further investigation, potentially involving X-ray data and follow-up observations using available UV facilities, such as, for example, AstroSat. And I thank you for your attention, and in case there are any questions, I will do my best to answer.